Okay, hello everyone. Welcome to Master the Codes, and today we are going to solve another important question asked in Amazon, that is rotting oranges. You can read the question if you wish, otherwise I'll directly take you to the description of the question and how it needs to be solved with the direct approach and the code, along with the notes provided. So please do not forget to like, share, and subscribe to the channel and hit the bell icon for more notifications. So without further wait, let's directly jump into the question. Okay, so today we are going to solve this particular question, that is rotten oranges. It has been asked by Amazon in multiple times, whether it be an SG role, an SWE role, or whether it be an AI machine learning role. This data structure problem has been asked multiple times by Amazon. Now let us understand what is the question all about. The first thing is you are given an array of size n and m, or rather a matrix of size n and m, where n may not be compulsorily equal to m. Okay, and you are given three values or other integers. You can suppose this as 2, you can suppose this as 1, and this one as 0, where 2 represents a rotten orange, n represents or 1 represents a normal orange, and 0 represents an empty space. Now, you are asked the question, can we rot all the oranges? And if yes, then at how much time we will need to rot all of them? Now, in the question, it is clearly mentioned the rot follows cardinally, right? It follows cardinal directions, top, down, left, and right. So it travels cardinal directions in a unit time, such that if you are over here in 1 unit of time, or in 1 second, you can say you will go to here and here. Then from these two places you will go to over here and here and here. But you will never be able to reach here because it is not cardinally adjacent. It is diagonally adjacent but not cardinally, right? So you cannot rot this particular orange. So in this case the answer is supposed to be -1, because it is impossible to rot all the oranges. Now the first intuition that you need to get is there can be multiple oranges in the grid, right? There's no, not given in the question that there has to be only one orange or there has to be only two oranges. There can be multiple oranges. So how to simulate it? Now since rod travels in the cardinal directions, that are 4 directions, and it is better to use Q for simulation of states. Now that gives us the idea that we need to use Q. Now when we are using Q, what is the data structure that we need? We need to pass an integer array that would contain the x and the y coordinates, because when we would do x plus 1 comma y, we can go right. When we will do x minus 1 comma y, we can go left. When we will do x comma y plus 1, we can go down. And when we will do x comma y minus 1, we can go up. So we will use the indices given to us. These indices, I'll mark them again, these indices given to us to put the first rotten oranges into the queue. Also, when we are traversing this grid in order of n square time, we will count the number of fresh oranges available to us, right? Now the question begins. We will start popping the elements from queue, or rather dequeuing the queue from the head. We will get this particular orange, and at every time, or rather at every second, using a BFS algorithm, we will rot the oranges cardinally, and while we are rotting the oranges, we will also store the count of fresh oranges from starting, and when the fresh oranges becomes rotten, we will decrease the count. Like you can see over here, we have 9 oranges, right, which are fresh. Now you can see only 3 oranges are available. The rest 6 oranges are already rotten. So clearly you can see over in this particular diagram, the 6 oranges are rotten and only 3 oranges are available. So the fresh count will become 9 minus 6 equal to 3, because whenever you will encounter a orange, or rather a value of 1, you will change it to 2 and decrease the fresh count by -1. Then similarly you will do it for time 2. You will get the rotten oranges more, you will keep on decreasing it, and when the BFS will end, you will get the fresh count, or rather if the number of oranges left. And if the fresh count of the oranges becomes 0, then all the oranges can be rot. Otherwise, it is impossible to rot all the oranges, because if you can see, if you look over this particular test case, you have one or rather two rotten oranges, and when you will start the BFS, you will capture most of the oranges, but you will not be able to capture this particular orange because it is not cardinally adjacent to any of the oranges, right? So that is how you will solve this particular question. I'll give you the code in the description as well, and will explain it also. Now if you look at the time complexity, it will be order of n square, because you will traverse every row and every column if in case if there is one rotten orange and all the other elements are n. And the space complexity will be also order of n square, because there can all the oranges can be rotten, so you need to store these n square values, or rather order of m into n values, into the queue. So that is for the explanation. I will jump into the code, but before that, please do not forget to like, share and subscribe to the channel, and hit the bell icon for more notifications. Okay, so this is the question. Here is the link as well for the same. If you wish, I'll be providing this entire code. Now, if you look at this question, I have initialized the grid and the count of the fresh oranges. I'm taking the input, right? Here is the next statement to take the input. And if the input is the fresh orange, I'll increment the count. This is an important step because that will give us the answer, whether it is possible to rot all the oranges or not. Then in the output log, we will be rotting all the oranges, running the function. And as explained in before, we'll create the queue of type an array, where the first index will store the x coordinate and the second index or the 1th index will store the y coordinate. And for initialization, we'll traverse the entire grid and find all the oranges which are rotten and add it into the queue with their x and y coordinates. That is the I and j, the j. Now, while the simulation is taking place, we'll find the size, the current depth of the queue, and extract the x and y coordinates of the head element one by one. And while we are doing so, we'll mark it as current element or the current coordinates as -1, because we do not want to backtrack. Like, it can happen if you go left, then the left cell will say there is one orange at the right, then you might jump to right again, which is backtracking, which we don't want. So we will give it any random value or other negative one value to mark it inaccessible. Now, if there is an orange at the left and that is not rotten, I'll decrease the count and add it into the queue. Similarly, I'll do it for the right. If a rotten or a fresh orange exists at the right, then I'll go for the top. If a fresh orange exists at the top, and similarly I'll go at the bottom. If the fresh orange exists at the bottom, decrease the count of the fresh orange and add it into the queue. And after this particular iteration, for that will be running till the size of the queue, the static size of the queue. After that, I'll increment the time to mark the time taken for the oranges to rot. Then I'll simply see if the fresh count after the simulation ends becomes 0. If the fresh count becomes 0, that means all the oranges are rotten. And I'll display the time as time -1. Otherwise, I'll simply put it as -1. Now, if I draw a test case for you, right? Let's make the screen a little bit bigger. Just a moment. If I draw a test case for you and give you a 3,3 grid, and let's say 1 is for fresh and 2 is for rotten, 1, 1 and 0, and 1, 1 and 0. And now if I press enter, it will give me -1. And if I start with this 3, just a minute, 3, 1, 2, 1, 1, 1, 0, 0, 0, and 1. And this will be giving me output as 2, which is the required answer. So thank you all for subscribing to the channel. Please don't forget to share the like button, and I'll be looking forward meeting you in the next video.